Electrical machines are electromagnetic energy conversion devices. Electrical motors converts electrical energy into mechanical energy, while electrical generators converts mechanical energy into electrical energy. In case of three-phase AC operation, most widely used motor is three-phase induction motor, as this type of motor does not require any starting device. For better understanding of the principle of three-phase induction motor, the basic constructional feature of this motor must be known to us. This motor consists of two major parts, stator and rotor. Stator of three-phase induction motor is made up of number of slots to construct a three-phase winding circuit which is connected to three-phase AC source. The windings are arranged in such a manner in the slots that they produce a rotating magnetic field when three-phase AC supply is given to them. Rotor of three-phase induction motor consists of cylindrical laminated core with parallel slots that can carry conductors. Conductors are heavy copper or aluminium bars which fits in each slot and they are short-circuited by the end rings. The slots are not exactly made parallel to the axis of the shaft but are slotted a little square because this arrangement reduces magnetic humming noise and can avoid stalling of motor.
The stator of the motor consists of overlapping windings offset by an electrical angle of 120 degrees. When the primary winding of the stator is connected to a three-phase AC source, it establishes a rotating magnetic field which rotates at the synchronous speed.
According to Faraday's law, an EMF induced in any circuit is due to the rate of change of magnetic flux linkage through the circuit. As the rotor winding in an induction motor are either closed through an external resistance or directly shorted by end ring and cut the stator rotating magnetic field, an EMF is induced in the rotor copper bar and due to this EMF, a current flows through the rotor conductor. Here the relative speed between the rotating flux and the static rotor conductor is the cause of current generation. Hence, as per Lenz's law, the rotor will rotate in the same direction to reduce the cause, the relative velocity. From the working principle of three-phase induction motor, it may observe that the rotor speed should not reach the synchronous speed produced by the stator. If the speeds equals, there would be no such relative speed, so no EMF induced in the rotor and no current would be flowing, and therefore no torque will be generated.
Induction motor rotor always rotate at a speed less than synchronous speed. The difference between the flux ns and the rotor speed n is short slip. Percentage slip is equals to ns minus n divided by ns multiplied by 100, where ns is synchronous speed and n is actual speed of rotor, and slip speed is equals to ns minus n. Self-starting, less armature reaction and brush sparking because of the absence of commutators and brushes that may cause sparks. Robust trim construction, economical, easier to maintain.